Hello, and welcome to Science with Mr. Morgan. In today's episode, we're going to learn about the scientific method and scientific units. So, to start off, what is an investigation in science? And I don't mean like a crime scene, although I guess forensics technically is science. By definition, it's how scientists add to scientific knowledge because it allows them to gain a better understanding of the world around us. It also produces evidence that helps answer questions. Now, even if these questions aren't directly answered, investigations can still be useful by possibly leading to new questions that can then be explored and potentially answered in the future by the same scientist or by other scientists that picked up their work. In order to complete an investigation, scientists follow something called the scientific method. What is it, you might ask? Well, let's break it down into the individual steps and see. Step 1, make an observation. Step 2, ask a question. Now that question should be related to the observation. Step 3, research it. See if someone else has asked that question before. See what information or material is out there. Step 4, form a hypothesis. What is it? You'll find out in a little bit. Step 5, test the hypothesis. Step 6, draw a conclusion based on your experiment or the test that you did for the hypothesis. And step 7, communicate the results. Now that we know what the steps are, let's go back and look at each step individually. So going back to step 1, it was make an observation. Well, to make an observation, we have to know what an observation is. An observation is something that you make using one of your 5 senses. Remember, your 5 senses are taste, hearing, sight, smell, and touch. Scientists often rely heavily on sight and hearing, but they do use all of their senses, depending on what they're observing. Why isn't taste very common in labs? Well, it's because many scientists use chemicals that are not safe for consumption, so you shouldn't be eating or drinking things in a lab setting. Anyway, back to observations. Throughout our conversation today, I am going to talk about an example regarding baking soda and vinegar, 2 common household items you've probably come across. An observation that I've witnessed is that when I mix baking soda and vinegar, I see bubbles form and I hear the bubbles popping. My vision and my hearing. The next step is step 2, ask a question. So based on your observations, you need to come up with a question that you want to find out the answer to. If we go back to our example, my question could be something along the lines of, why do bubbles form when baking soda and vinegar mix? In order to answer that question, my next step would be step 3, research. During this step, you're going to research to see if anyone else has asked the same question or even a similar question, because sometimes similar questions can help provide answers you're looking for. You're also looking for what information is available about the question that you're researching. So with our example, I would use resources available such as search engines like Google or books to look up what information there is about baking soda and vinegar. You want to make sure that your sources are reputable, which means they have a good reputation and are trustworthy. Generally, websites that end in .org or .gov or .edu even tend to be more reputable. The next step is step 4, form a hypothesis. Well, what is a hypothesis? Essentially, it's an educated guess based on your observations. That being said, hypotheses have to meet 2 criteria. The first is that a scientific hypothesis must be testable. This means that you make observations that agree or disagree with it. Now, when I say that, do I mean that the observation has to verbally tell you if it agrees or disagrees? No. All that means is that the observation supports your claim or shows that your claim might not be true. The second criteria is that a scientific hypothesis must be falsifiable. This means that it must be proven to be false if it is truly false. Now, if we look back at our example, my hypothesis is if I mix baking soda with vinegar, then a chemical reaction will happen and bubbles will form. Notice, this hypothesis follows an if-then model. This is a simplistic way of writing a hypothesis. If something happens, then it will cause something else to happen. You fill in the something portions of the sentence based on your observations and thoughts. As scientists progress, they get more complicated with their hypotheses. The next step is step 5, test the hypothesis. During this step, you develop an experiment to test your hypothesis. This experiment will have dependent and independent variables, as well as a control or multiple controls. Make sure you record all data when doing this experiment, because the more data you have, the better it will be for you. Back to our example, I've observed that baking soda and vinegar form bubbles when mixed, and now I'm testing to see if that is true. To test it, I'm going to perform my experiment. To keep this simple, I'm only going to test this a couple different ways. The first way is I will mix 1 milliliter of vinegar with 0.5 grams of baking soda. Then I'm going to record what happens, because remember, the more data you have, the better. Next, I'll mix 1 milliliter of vinegar with 1 gram of baking soda. Again, I'm going to record what happens. Now that I've done those things, I'm going to repeat each of these 2 more times and see what happens, or record what happens each time. Before we move on to the next step, I mentioned different kinds of variables. So what are they? Well, there are multiple variables in a hypothesis. One type are the independent variables. These are the variables that are changed by the researcher and scientist. Another type are dependent variables. These are the variables that are affected or impacted by the change that the researcher or scientist made. They didn't change them directly, they're just impacted. And the last type are control variables. These variables remain constant throughout the experiment, so that way they don't change it one way or another. Now, let's connect these variables to our example experiment. The amount of baking soda changed in our 2 versions of the experiment. What type of variable would that be? If you said the independent variable, you would be correct. So if the baking soda that changed each time was the independent variable, what is the dependent variable? Well, what could have changed if the amount of baking soda changed? Was it the vinegar? No, that stayed the same amount each time. Both times was 1 milliliter. So that is considered a control variable because it remained constant. If it's not the vinegar, then what could it be? Well, let's look at what happened. We mixed the vinegar and the baking soda. Bubbles ended up forming. Different amounts of baking soda are going to cause different amounts of bubbles produced because the amount of the reaction is changing. Therefore, the amount of bubbles produced is the dependent variable. It changed because of the change that we made with the amount of baking soda. On to the next step. Draw a conclusion. First of all, what is a conclusion? A conclusion states whether or not the experiment supports your hypothesis. If you state that it does, you must provide the evidence from your experiment that supports your hypothesis. You are defending the stance that you take. If you state that it does not support your hypothesis, the conclusion can be used to make adjustments to your original hypothesis to be tested in a new experiment down the road. Sometimes scientists observe things that make their hypothesis partially true, but the parameters or guidelines of the experiment need to be adjusted to test what they're really looking for. Then they can go back and test it again with a new hypothesis or a new experiment for the same hypothesis. So if we look at our example, bubbles formed when baking soda was mixed with vinegar, which supports my hypothesis. In all steps of the experiment, bubbles were produced. Now the last step is step 7, communicate the results. Typically you're going to write these results up in a lab report, and it could be a formal or an informal report depending on what you're looking to do with your experiment. Remember how I said the more data you had, the better? This is one part where that data comes into play. If you ended up finding that your hypothesis was true, you want to have the data to back that up for others who may be unfamiliar with your experiment or want to try and recreate it. If they can't recreate it, your hypothesis might not be true. If you found your hypothesis to be false, you want to have the data to show how or why it is false. That about sums up our conversation regarding the scientific method. If you remember at the start of this video, I said we would be talking about the scientific method and SI units. So what are SI units? This is the measurement system used by most scientists and engineers all across the world, otherwise known as the International System of Units. But scientists like to keep things short, so we use SI units for short. Here in the US, the general person uses different measurements for some of our measurements. These include Fahrenheit for temperature, inches or feet for length, and pounds for weight. The general SI units are Kelvin for temperature, although a lot of people also use Celsius, meters for length, and kilograms for mass, which mass is different than weight. Other SI units also include moles for the number of particles. And no, I don't mean mole like the animal or what is on someone's skin. It is separate. Amperes for current, and seconds for time. Now, just a few seconds ago, I mentioned meters. You're probably familiar with this unit of measurement in the form of centimeters, which are found on the side of a ruler opposite inches or feet. Notice that the word meter is found in the word centimeters. Centi is a prefix, which is what all SI units use. These units are based on the number of 10, and this means that the basic units are multiplied or divided by powers of 10 to arrive at bigger or smaller units. There are a lot of different prefixes which are used to indicate the different powers of 10. 1 centimeter is 10 to the negative 2, or 100 times smaller than the meter. These prefixes include the kilo, which is 10 to the 3, or 1,000 times larger than the base unit, deci, which is 10 to the negative 1, or 10 times smaller than the base unit, centi, like I've already mentioned, is 10 to the negative 2, or 100 times smaller than the base unit, milli, which is 10 to the negative 3, or 1,000 times smaller than the base unit, micro, which is 10 to the negative 6th, or 1,000,000 times smaller than the base unit, or nano, which is 10 to the negative 9th, or 100 million times smaller than the base unit. If we compared these to meters, we would have that 1 kilometer is equal to 1,000 meters. 1 decimeter is equal to 0.1 meters. 1 centimeter is equal to 0.01 meters. 1 millimeter is equal to 0.001 meters. 1 micrometer is equal to 0.000001 meters. 1 nanometer is equal to 0.000000001 meters. Might have missed a zero in there. Are these the only prefixes, though? Nope. There are others as well. Now, earlier I mentioned in the US that we use measurements like pounds and inches. SI units can be converted to their English equivalents, just like the English version equivalents can be converted to SI units. And that brings us to the end of today's lesson. Until next time.